In this exercise, we started off with a basic cloud infrastructure architecture that did not have much in terms of security controls. If we look at the architecture, you should notice three distinct design decisions. First, the security groups that have been applied to all resources allow all incoming traffic. They are not restricted to specific source networks or ports. Second, all requests that go to Mailgun are going through a NAT gateway to get to the internet. Third, our internal team members do not have connectivity to the Kubernetes cluster and database. Let's see how we can incorporate security into this design. Let's start off with modifying the security groups. The first security group for the load balancer doesn't need to be modified because for this type of web traffic, it is already specific enough. The second security group for the application server can be made more specific. We should set it up so that it only allows connections from the load balancer on port 443 and also from the VPN security group on port 8443. The database security group should be updated to allow connections from the application and from the VPN security groups on the database port. We have also implemented the client VPN solution, which will allow authenticated users to connect to resources in the cloud environment. We can allow access to specific subnets based on the user's role. We can restrict developers and DevOps engineers to be able to access the application subnets. And we can restrict members of the analytics team to be able to access the database subnets. Finally, we want to ensure that outbound traffic from the applications to the internet is restricted and monitored. We can use a proxy server farm to accomplish this. In this case, our proxy servers could be configured to allow connections to mailgun.com and block all other connections.